pick, how do you get to the next point you see? You go down 2 over 1. Yeah. Right? What about if I went from this point to that point? Well, then I go down 2, 4, 6, and then over 3. Negative 6 over 3 is still negative 2. So as long as the line is straight and it doesn't curve, the slope can't change suddenly. If the slope changes, that means there must be a curve somewhere. Okay, maybe. So what about this one? Can you guys see the y-intercept?
Yeah.
So we know what b is.
3.
B is 3. I'm not sure why it's like the only number that's not there.
3.
And then what's the slope? So you go from here to the next one, I go up 1,
1.
over 1.
1 over 1.
So m is 1. And then you can put the equation together. Y equals mx plus b. So if I know the y-intercept and the slope, I can put together the line. If I know the line, I should be able to see the y-intercept and the slope. I like
Isn't that
that's
supposed to be
interesting.
negative?
Say again, sorry?
Negative?
Why would it be negative? The y-intercept, not the x-intercept. Yeah. In fact, watch this. I like you see how the x-intercept is, what is the x, what is that point right there?
Negative
3? 0. If you put a negative 3 in for x, what do you get? Negative 3 plus 3?
3.
Negative 3 plus 3
0.
is 0. Sure enough, that point works. Right? So it does work. But be careful, the y piece of the y-intercept goes here. It has nothing to do with the x-intercept in general. Yes?
How did you get b equals 3 again, please?
Where does it hit the y-axis?
From 0?
Where does that line hit the y-axis?
Oh, right there.
And
But,
what's the y point in this?
oh, what did you say?
3.
3. So b must be 3. b is the y piece of the y-intercept. What is the y-intercept? It's where it hits the y-axis.
0.3.
0, 3, yes. But b is 3.
Yes.
You could say that and not feel any need to be careful with me. b is 3.
Mhm.
I like it.
The x is 0.
Yes, the y-intercept is 0, 3. I like it. All right, last thing for today. This is a really weird day. I'm getting an interesting vibe in here, but like, shut up, Matt boy, just do it. Okay. Last thing I want to talk about is something that came up just a minute ago, and y'all know what it parallel means. I like it. What the hell's perpendicular mean? You can read that, but I mean, I'm just trying to give it away. But please, do you guys know what perpendicular means? Parallel means they never cross, they never meet, they never touch, they never intersect, right? They're just always the same distance away from each other, right? I like it.
Perpendiculars were there eventually not touch, right?
No.
Are they already
How many ways can two lines intersect?
minimal?
Infinite number, but perpendicular is specifically where they make what kind of angles? 90-degree angles. So that's why it's kind of like the exact opposite of parallel is perpendicular. I like it. So what the shit does that mean? So why does this make sense? You might be reading that. I don't care. Look at me. Parallel lines, what must be true about their slopes? They have to be exactly the same, right? If one guy had a little bit bigger or smaller slope, it would eventually run into the other guy. So two parallel lines must have exactly the same slope. Now here's what's a little freaky. And here's why I say it just like that. Two perpendicular lines actually end up having interesting slopes. So if I had one line that was like that, that's kind of a big positive slope, right? If I draw something that's perpendicular to that, would be something like that maybe. Make a 90. You guys agree with me those are perpendicular?
No.
You're like, no? Why?
Because you said they should never.
Parallel never meet. perpendicular make 90-degree angles. I like it. So obviously, if one has a positive slope, what must be true about the other one? Looking at this. So in general, if one has a positive slope, the other one must have a negative slope to come at it at the right angle, right? Let's make that x. I love it. But the one that's a little more hidden, that doesn't make as much immediate sense to us, is that they have to also be reciprocals of each other. So if I make this kind of more extreme, can somebody tell me something about the slope of this line here? Is the slope of that line very big? Hell no, because it's not doing what much? It's not rising much. And if I draw the perpendicular line to that, that is huge. Negative slope, isn't it? This one's almost flat. Is this one almost flat? No, this is almost exactly not flat. So if this guy had like a -3 slope, this guy would have a 1/3 slope. So that's why I love to say it like this. Parallel lines have exactly the same slope. Perpendicular lines have completely opposite. And there's two kinds of opposites we know. Different signs and reciprocal, right? So they do both. So parallel, totally the same in every respect. Perpendicular, totally opposite in every respect. That's kind of a cool way to remember it, maybe. So if I had a slope, if I had a line, the first line slope is -2. What would the perpendicular line slope be? No. Thanks for playing. You got one thing right. I want you to make it completely opposite. Change the sign and there it is. It'd have the slope of 1/2. There it is. So make it totally opposite. Change the sign and flip it. So what if I had a line that had a slope of -3/4? What would the perpendicular line have? Positive?
4/3.
4/3. Bam. Change the sign, flip it. Parallel? Same in every way. Perpendicular? Opposite in every way. And for some reason, this never did much for me, but I've noticed some students like this, the two numbers have to multiply to be -1. So I don't know if that helps you out. Great. I mean, obviously they do. What do two reciprocals multiply to be? If you multiply something by its reciprocal, you get, come on.
Cancellation.
Totally. So what would you get? So what's the reciprocal of 7/9?
9/7.
9/7. What do you get when you multiply those together? 1, right?
Oh, yeah.
What if one of them was negative? Then the answer would be -1. So that's all this is saying. If these two are negative reciprocals of each other, their product will be -1. If that doesn't help you at all, you can just go with what I said earlier, which is the way I always looked at it. Ever since I was a little math boy. All right. So watch this. If two lines are parallel and the slope of the first line is -2, what's the slope of the other line?
+2.
Parallel,
Oh,
Parallel. -2. Done. Parallel lines have to have the
Same.
exact same slope. Bam. Two lines are perpendicular. Two lines are perpendicular. Slope of the first line is 2/5. What's the slope of the other line?
5 times.
-5/2. I like it. Yes, yes? If two lines perpendicular, the slope of the first line is -3. Yes, positive 1/3. Change everything about it for perpendicular. Leave everything the same for parallel. Now, how do you do this shit? If I ask you if two things are parallel or perpendicular, what must you know to be able to tell? They're slopes. Can you figure out the slope for each of those? What's the best way to figure out the slope for those? Solve it for y. Do it. Figure out the slope for each of those lines that I give you, and then you can tell if they're perpendicular, parallel, or neither. No, I don't want you. Go away. How did I get you? Scheisse. No, it got even worse.
Oh gosh,
Shit.
fuckers.
Uh,
Go home.
I don't even know. I didn't push anything freaky. I might have to just turn it off and start over. Oh, there's return. Where's return? That's stupid. All right. Save and exit. Thank God. Okay.
Yeah.
I can't tell what the m is the way it is, can I? I have to get what by itself? What? Y. So here, if I subtract 6x, divide by -3, I get y equals 2x minus 4. Is that right? The two negatives cancel there, and here I get negative. If I do the same thing with that one, it's not going to be as bad because I just subtract x, then divide by 2. I get y equals -1/2 x plus 2. Let me stop there for a second. No, it's good. That's a good sound. So are they parallel, are they perpendicular, or are they neither? They're definitely not parallel, right? But are they negative reciprocals of each other? Yes. So therefore they are perpendicular. Yeah. I like it. By the way, while I'm thinking about it, the symbol for perpendicular is that. So if I want to say line 1 and line 2 have perpendicular slopes, that's how I would say it. M1 perpendicular M2. I actually say, anyways. And this is, yeah, yes, sir?
Yeah, yes.
All right. What about these two? Yes?
Is there a symbol for parallel?
Yes, there is. I was going to see if something came out parallel, but it isn't. Parallel looks like, this is kind of nifty. It looks like the two L's, and it looks like two parallel lines. So I could say M is 2, M parallel is 2, for example. So here, this one's nice. This one's done. Slope is 2, kick ass. This one, shit. Get out of there. Add x over.
Okay. We don't see number with the y, it's gonna be the m's too.
Say again, what?
The y, does it have a number, y?
This here?
Yeah.
So it's solved for y, which means it's y equals mx plus b, so I can see m is 2. If there was a number with a y, I would divide it away. I would kill that thing. It's just like here, there's a 2 in front of the stupid y. So I kill the 2. Y equals 1/2 x plus 3. Are they parallel? No, because the slopes aren't the same. Are they perpendicular? No, because the slopes aren't negative reciprocals of each other. So they're just neither, because there's an infinite number of things that could be otherwise. It could be this, or this, or this, or this, or this, or there's, yes?
I don't get how to find the negative reciprocal.
You know how to find a reciprocal, right? Okay, and then just change the sign. That's what negative reciprocal means. So if I had 7/3, the negative reciprocal is -3/7. Just change the sign and flip it. That's it. All right, last thing for today, just to put this weird ass day to an end. This one's one of the more interesting ones. What two things do we need for the equation of a line? We did this already. We figured out equations of lines on the other side of this. What two things do we need? Slope and y-intercept would be great. Later we're going to learn what if we don't know the y-intercept is, we just have another point, we'll actually be able to do it still. But if I know the slope and the y-intercept, it kicks so much ass, because then I know what m is and I know what b is, which is all I need, right? So in this problem, did I give you either one of those directly? Did it just tell you one of those? Yes, I did.
Oh, yes.
Y-intercept is 0, -3, so what's B? B is -3. Become a thing. There we go. How do I figure out what M is going to be? What information did it give you about our line?
So we get opposite reciprocal of that slope.
Yeah, it's perpendicular to this line. So if I just knew this line's slope, I could figure out our slope. Do you guys see that?
Yeah.
So how do you figure out this guy's slope?
Get y by itself.
Get y by itself, do it.
So
You should end up with this.
isn't it negative one?
Yeah, it'd be -1, but they cancel each other out.
It is -1. What do you mean -y? Okay, let me show you the steps. I was just telling you the answer. All right. You ready? Right? And that's not done yet because you don't have y by itself yet. Divide by -1.
And you get y.
I like it.
That's what I was saying, like the one cancel, it makes it into, because of negative times negative is positive, so it makes it.
Sure.
positive.
Okay. So what's this guy's slope? 2. So what's our slope?
1/2. -1.
There it is. You guys with me? Every piece of what we're doing right now, we've done before. We're just doing a lot of it in a row for one problem. So that's why I think where students sort of disconnect. You're like, no, this can't be this much work. I must be doing something wrong. No, it is. In order to figure out the equation of a line, I need the y-intercept. Kick ass, I got it. And I need the slope. Ah, shit. I don't have the slope. What do they tell me? Perpendicular to this guy. Ah, God. I got to know this guy's slope, and then I can figure out my slope. So it is a chain of events. Okay, to know this, I got to know this. To know this, I got to do this. So then you do it, and you kind of work your way in the direction you know you need to get. So now I can say what my slope is. That slope is 2. My slope is -. No.
-1.
The perpendicular, negative reciprocals.
Oh.
All right, change the sign and flip it. Yes.
So this one worked out where like the original problem is the same, just without the negative. That makes sense?
How do you mean?
The 2x minus y equals 1.
What about it?
Well, you know 2x is going to be the slope. Is that normal for most problems? Like if
Well,
you didn't if you didn't solve it,
I know
could
what you
just-
mean, but you don't know when you can do that. It's because I add y over,
Right. It's just
and I
negative
leave the
stuff.
2x alone. Do you see what I'm saying? So the 2 doesn't get changed.
I understand that, but that's not what I'm saying. I'm saying you could just take the 2x and say that's the slope because we know what it is.
But that's because of what I just said.
Okay.
Nothing happens to the 2x that when you're solving the equation, because once you add y over, you're fundamentally done. You've gotten y on the other side. 2x has nothing happen to it. So that's why 2 is the slope even from now.
Right. It just undid itself.
Can you always tell when that's going to happen ahead of time?
No.
No. So, yeah. I like that though. You're right. So now I can put it together. Generally, it's mx plus b, and now I just throw in there what m is. -1/2. X plus, and in fact, it's going to come out to be. So let's clean this up again. 1 -1/2 x minus 3. Bam. You guys like that one a lot, I can tell. All right. So what we're doing, what we actually just did was we sort of did 4-5 and a part of 4-6. The last part of 4-6 we need to do is this here. But like I just said, let's go ahead and call it. This is a weird day. Let's let this day end, and then we'll pick up there on Monday. Okay.